The summer of 2005 brought relentless heat to David Miller's Kansas farm. Dust swirled across his cornfields, the stalks brittle and yellowed long before harvest. For generations, his family had coaxed life from this land, but the old irrigation ditches, fed by dwindling groundwater, were no match for the intensifying drought. David walked the parched earth, the weight of his family's legacy, and the looming threat of crop failure heavy on his shoulders. He knew he needed a miracle, or at least, a radically new way to water his fields. David's farm spanned thousands of acres, a patchwork of fertile soil that, under normal conditions, promised abundance. But the sheer scale of watering such an expanse was a monumental task. Traditional flood irrigation was wasteful, and moving portable sprinklers by hand was a labor-intensive, often impossible, endeavor during critical growing periods. Farmers like David faced a constant battle against nature's unpredictability, with the very survival of their livelihoods hinging on their ability to deliver water efficiently and reliably. Word had reached David about a new kind of irrigation, something almost alien in its design and operation. His neighbor, Sarah Jenkins, whose fields always seemed to thrive even in dry spells, spoke of a silent giant that moved without human hands, watering vast circles of crops with uncanny precision. It sounded too good to be true, a technological marvel that promised to defy the limitations of manpower and traditional water delivery. Could such a machine truly be the answer David desperately needed? 3 weeks later, David stood at the edge of Sarah's property, staring. Stretching nearly 1,000 feet across her field was a colossal lattice of steel towers, each with a set of wheels, connected by a long pipeline. It wasn't static, it was moving, slowly, imperceptibly, circling a central point. Water misted gently from nozzles along its immense length, creating a shimmering arc against the morning sun. This was the silent giant Sarah had described, a center pivot irrigation machine, and it was watering her entire field, seemingly on its own. At the very heart of this immense contraption was the pivot point. This central tower, anchored firmly to the ground, was the only stationary part of the entire system. Here, the lifeblood of the farm water was pumped from a deep well, or sometimes a nearby pond, into the main pipeline. It was the linchpin, the axis around which this mechanical arm performed its slow, deliberate dance, delivering moisture to every corner of its vast circular domain. Without this central hub, the entire system would be motionless. Extending outwards from the central pivot, a series of individual towers supported the long pipeline. Each tower, standing on its own set of wheels, was a critical component, ensuring the machine maintained its structural integrity across hundreds of feet. These towers acted as the legs of the giant, distributing its weight and allowing it to traverse the uneven terrain of a vast field. Their sturdy design was essential for the system's stability and consistent operation, especially when laden with thousands of gallons of water. What truly fascinated David was how this colossal structure moved. There was no tractor pulling it, no operator visible. Each wheel tower, it turned out, housed a small electric motor. These motors, connected to the main control panel at the pivot, worked in precise unison, propelling the towers forward. The machine was designed to move very slowly, ensuring uniform water application. It was a marvel of quiet automation, a testament to engineering that could command such a massive machine with barely a whisper. The speed of the center pivot machine was astounding in its slowness. It could take up to 3 days for a 1,000-foot system to complete just one full circle, a testament to its meticulous approach to hydration. This deliberate pace wasn't a flaw, it was a feature, allowing the water to soak deep into the soil rather than run off, and ensuring every plant received its precise share. This slow, continuous movement was key to its efficiency, a stark contrast to the rapid, often wasteful, bursts of traditional sprinklers. Perhaps the most revolutionary aspect of the center pivot machine was its autonomy. Once programmed from its central control panel, it operated without a human driver or constant supervision. This self-sufficiency freed farmers like Sarah from the grueling, round-the-clock task of manual irrigation, allowing them to focus on other critical aspects of farm management. It was a paradigm shift, transforming the nature of farm labor and offering a glimpse into a future where machines handle the repetitive, physically demanding tasks. The effectiveness of the center pivot lies in its precision. Instead of blasting water indiscriminately, the nozzles along its length are designed to spray water in specific, controlled patterns. This targeted application ensures that water reaches the plant roots directly, minimizing evaporation and runoff. It's a stark contrast to older, less efficient methods that often resulted in significant water waste, where much of the precious resource never even reached the intended crops. This directed approach maximizes every drop. For regions plagued by drought and dwindling water resources, the center pivot system offered a lifeline. It dramatically reduced water waste compared to traditional flood irrigation or even older sprinkler systems. By delivering water exactly where and when it was needed, it ensured that the farm's most precious resource was used with unparalleled efficiency. This wasn't just about saving money, it was about sustaining agriculture in increasingly arid environments, making previously unfarmable land viable once more. When compared to older irrigation methods, the difference in water usage is striking. Flood irrigation, while simple, could see up to 50% of water lost to evaporation, runoff, or deep percolation beyond the root zone. Hand-moved sprinklers offered some improvement but still lacked precision and required immense labor. Center pivot systems, however, often achieve water efficiency rates exceeding 90%, a critical factor in regions where water is a finite and increasingly scarce commodity. This efficiency is a game-changer. The versatility of the center pivot extended far beyond mere watering. Its sophisticated delivery system could also be used to apply vital nutrients and even pesticides directly through the water stream. This method, known as chemigation or fertigation, ensured uniform distribution across the entire field, reaching every plant simultaneously. It optimized resource use, minimized waste, and reduced the need for separate, often costly, application passes with other farm machinery. It was an integrated solution, making farm management more efficient. For David, the promise of the center pivot wasn't just about water, it was about time. Weeks of moving hoses, adjusting sprinklers, and monitoring floodgates would be eliminated. This freedom allowed farmers to dedicate their precious hours to other critical tasks, planning crop rotations, maintaining equipment, or even spending more time with their families. The machine didn't just save water, it saved lives from the relentless grind of traditional farming, offering a quality of life previously unimaginable for those tied to the land. After witnessing Sarah's thriving crops and hearing her glowing testimonials, David made the difficult decision. The initial investment for a 1,000-foot center pivot system was substantial, a risk that could either secure his farm's future or plunge it deeper into debt. But the alternative, continued reliance on unpredictable rainfall and inefficient traditional methods, felt like a slower, more agonizing path to failure. He saw the pivot not just as a machine, but as an investment in resilience, a desperate gamble for survival. The ingenuity David admired had a distinct origin. In 1940, in the arid landscape of eastern Colorado, a farmer named Frank Zyback faced challenges not unlike David's. Traditional irrigation methods were inefficient, and manual labor was exhausting. Zyback, a self-taught mechanic with an inventive spirit, dreamed of a better way to water his crops, one that could handle the vast, flat expanses of the Great Plains. His vision was simple yet revolutionary, a system that moved in a circle, watering uniformly as it went. Zyback spent years tinkering, driven by necessity. His initial designs were rudimentary, far from the sophisticated systems David saw today, but the core principle was there: a central pivot, a long pipe, and wheels to propel it. In 1940, he finally developed a working prototype, a testament to his perseverance. It wasn't just an invention, it was a conceptual leap that would fundamentally alter the agricultural landscape, starting from a small farm in Colorado. Zyback refined his design through the 1940s and eventually secured a patent in 1952. His invention wasn't immediately embraced, it was a radical departure from established practices, requiring significant upfront investment. Early farmers were skeptical of its efficiency and durability. Yet, the persistent problem of water scarcity in arid regions, coupled with the growing demand for food, created an undeniable need for such a solution. the stage was set for a quiet revolution. It was in the 1960s and 70s that center pivot irrigation truly began to gain widespread popularity. Advances in materials, improved manufacturing techniques, and a better understanding of its long-term benefits convinced more farmers to adopt the technology. Government subsidies and agricultural extension programs also played a role in accelerating its spread. What began as one farmer's solution to his own challenges quickly became a cornerstone of modern agriculture across the globe, transforming vast landscapes. The impact on arid regions, particularly in the American West and Midwest, was nothing short of revolutionary. Land once considered unsuitable for crops due to lack of water could now be made productive. This transformed regional economies, creating new agricultural opportunities and securing food supplies. The green circles of irrigated crops, visible even from space, became iconic symbols of human ingenuity conquering environmental limitations, turning deserts into breadbaskets with remarkable consistency. The success of center pivot irrigation quickly transcended national borders. From the vast plains of Saudi Arabia to the fertile lands of Australia, and across Africa and Asia, the technology spread, adapting to diverse climates and crops. It offered a scalable solution to the global challenge of feeding an ever-growing population, providing food security in regions previously vulnerable to famine. The silent giant became a global workhorse, a testament to its universal applicability and enduring effectiveness. Despite its undeniable benefits, the initial investment for a center pivot system remains substantial. Installation involves significant upfront costs for the machinery itself, along with expenses for drilling wells, installing pumps, and establishing power lines. This financial hurdle can be a major barrier for many farmers, especially smaller operations. It represents a long-term commitment, requiring careful financial planning and often necessitating loans or government assistance to make the transition possible for many. However, for those who can make the investment, the long-term payoffs are considerable. The dramatic reduction in water use translates directly into lower utility bills and more sustainable resource management. Labor costs are significantly cut, and the increased yield from consistently watered, healthy crops boosts profitability. Over time, the center pivot system often pays for itself many times over, transforming struggling farms into thriving, resilient enterprises. It's an investment in future stability. While self-operating, these complex machines are not entirely maintenance-free. Regular checks are crucial to ensure optimal performance. Farmers must inspect nozzles for blockages, monitor tire pressure on the wheel towers, and routinely check the electrical connections in gearboxes. During critical growing periods, when consistent watering is paramount, even a small malfunction can have significant consequences. Preventative maintenance is key to avoiding costly downtime and ensuring a successful harvest. For crops like corn, certain growth stages are incredibly sensitive to water availability. Missing even a single day of irrigation during these critical periods can severely impact yield and quality. This is when the reliability of the center pivot system shines brightest. Its consistent, programmed delivery ensures that crops receive exactly what they need, precisely when they need it, safeguarding the farmer's investment and the year's harvest from environmental stress. It's a guardian of the growing season. Just as Xybacca's initial design evolved, so too has the center pivot system. Modern iterations incorporate advanced technologies that enhance their precision, efficiency, and ease of use. What began as a purely mechanical innovation has integrated into the digital age, reflecting the continuous pursuit of optimization in agriculture. These advancements ensure the system remains at the forefront of farming technology, adapting to new challenges and pushing the boundaries of what's possible. Today's center pivot systems often feature GPS guidance, elevating precision to an entirely new level. Farmers can program exact watering zones, adjusting water application rates based on real-time soil moisture data or varying crop needs across the field. This pinpoint accuracy minimizes waste even further, prevents overwatering in certain areas, and ensures that precious resources are allocated only where they will have the most impact. It's a truly intelligent approach to irrigation. For busy farmers like David, the ability to monitor and control their irrigation systems remotely is a game changer. Using smartphones or computer tablets, they can check system status, adjust water schedules, and even receive alerts for potential issues from anywhere in the world. This remote access not only enhances convenience but also provides peace of mind, knowing that fields are being watered optimally even when the farmer isn't physically present. The farm can truly be managed from a distance. Modern center pivot systems generate a wealth of data on water usage, soil moisture, nutrient application, and even weather patterns. This data is invaluable for making informed, data-driven decisions that optimize crop health and resource efficiency. Farmers can analyze trends, predict needs, and fine-tune their irrigation strategies for maximum yield and sustainability. It transforms farming from an intuitive art into a precise science, backed by quantifiable metrics. Years after his crucial investment, David Miller's Kansas farm tells a different story. His fields are lush and green, even during the driest summers. The 1,000-foot center pivot moves silently, a testament to resilience and adaptation. David now spends less time battling the elements and more time planning for the future, confidently facing the challenges of modern agriculture. The initial gamble paid off, securing his family's legacy and turning despair into prosperity through innovative technology. The center pivot irrigation system embodies a crucial step towards sustainable agriculture. By conserving water, reducing chemical runoff, and optimizing resource use, it minimizes the environmental footprint of large-scale farming. It allows us to produce more food with fewer resources, a vital consideration as the global population continues to grow. This silent giant is not just a machine, it's a model for how technology can help balance human needs with ecological responsibility. In a world grappling with food security and climate change, the role of technologies like center pivot irrigation becomes even more critical. It enables the consistent production of essential crops, ensuring stable food supplies for millions. Without these advancements, many regions would struggle to feed their populations, making this technology a cornerstone of global food production and a key player in the ongoing effort to eradicate hunger and strengthen agricultural resilience worldwide. The 1,000-foot irrigation machine, moving tirelessly without a driver, stands as a silent guardian over vast fields. It represents the quiet revolution happening in our agricultural heartlands, a blend of simple mechanics and sophisticated technology working in harmony with nature. It's a powerful reminder that some of the most profound innovations are not the loudest, but those that quietly transform lives and landscapes, securing our future one circular field at a time. Frank Sybaka's initial vision, born from the dusty fields of Colorado in 1940, has blossomed into a global phenomenon. His ingenious solution continues to evolve, adapting to new environmental challenges and technological possibilities. It's a powerful testament to the impact one individual's perseverance and inventiveness can have, shaping the very foundation of how we feed ourselves. The green circles seen from above are his enduring legacy, a mark of human ingenuity on the land. As we look to the future, the integration of artificial intelligence, advanced sensor networks, and even more sustainable energy sources promises to push the capabilities of center pivot systems even further. These machines will continue to play a vital role in precision agriculture, ensuring that farming remains productive, efficient, and environmentally responsible. The silent giants of the fields are still evolving, ready to meet the challenges of tomorrow's world. The story of the 1,000-foot irrigation machine is a narrative of an invisible hand shaping our world. It's the story of innovation born from necessity, of technology empowering human endeavor, and of a quiet revolution transforming the very land beneath our feet. From David Miller's parched Kansas field to countless farms across continents, these silent giants continue their slow, relentless dance, a testament to what's possible when human ingenuity meets the fundamental needs of life.